All right, guys, so this is the second half of section 12.5. If you haven't watched the first half, please do that. The first half we talked about permutations, and in this half, or in this video, we're going to talk about combinations, okay? So if you remember back to when we started our vocabulary, permutation is when order matters. Combinations now, order does not matter, okay? And we kind of did two examples here of a permutation and a combination. And so when we're doing combinations, this is the formula we would use, okay, right here. And this here is an example of how we'd use it if we had numbers. But we would say this as this in big CR is in choose R. Okay, so this would be how many choices we have, or maybe I should say how many total choices, and then how many we are choosing. And hopefully after we do a couple of examples, that'll make more sense. But anyways, it's in choose R. All right, so let's look at example 3A. It says here, count the possible combinations of two letters chosen from A, B, C, and D. Okay, now remember, we're talking about combinations, so order doesn't matter. So we're assuming that like AB and BA, this would be one combination, okay? Because they're both a combination of letters A and B. So we could do this two ways. We could, I mean, this is small, so we could really write it out. We could say, well, we could have an A and a B, an A and a C, or an A and a D. And remember, DA would be the same as AD, CA, so on. Or we could have a BC or a BD or just a CD. Okay, we could, with it small like this, we can write this out. 1, 2, 3, 4, 5, 6. So there would be 6 total combinations we could have. Okay, or if we wanted to do it by the formula, I just want to show you that you get the same thing. It would be 4 choose 2, right? There's 4 total letters, and we're choosing 2. Okay, so 4 choose 2 equals, now our formula, if we go back to our formula, I have n choose r equals n factorial over parentheses n minus r factorial times r factorial. Okay, if you don't know where I got that straight from here. All right, so n choose 2, or 4 choose 2, so this is our n, and this is our r. Okay, so if we go off of this formula, our n factorial, our n is 4, so it'd be 4 factorial over n minus r, so 4 minus 2 factorial times r factorial, which is just 2 factorial. Okay, so if I simplify this, this is just 4 factorial over n minus 2 is 2 factorial times 2 factorial. Okay, all right, if I simplify it a little bit more, this is 4 times 3 times 2 times 1, or just 2 factorial over 2 factorial times 2 factorial. The reason I did that, 2 factorial over 2 factorial cancel out, so just 4 times 3 is 12 over, well guys, 2 factorial is just 2 times 1, which is 2. 12 over 2 is 6. Okay, so we get the same answer regardless of either method we use. All right, so using 3A that we just did together, I want you to go ahead and do 3B on your own. Now you could use it by just listing the letters and finding the combinations, or you could do it by using the formula. I highly advise you at least double check yourself by the formula, because if this is, I don't know, every letter of the alphabet, you would not want to draw this out by hand. All right, so if you list them all out, this is your list here, and you could count them up and you should get 10 combinations. Now remember, we're considering ABC the same thing as CBA, right? We're just worried about how many combinations of letters. We don't care about the order they're in, okay? And if you do it by the formula, it would be 5 choose 2 because there's 5 total letters. Sorry, 5 choose 3, and we're choosing 3 of them. Okay, so it'd be 5 factorial over 5 minus 3 factorial times 3 factorial. Okay, you simplify it all out, you would get the same answer. All right, so let's look at example 4 now. It says you order a sandwich at a restaurant and you can choose from 2 side dishes from a list of 8. Okay, so there's 8 total, and you choose 2. Okay, so now the question is this a combination or is it a permutation? In other words, does it matter? Does order matter here? So is picking mac and cheese and French fries the same thing as French fries and mac and cheese? Well, yeah, clearly it is the same thing. We don't care which one's on the left side of our plate, which one's on the right side of the plate, or whatever. So this would be a combination. Okay, so our combination would be 8 choose 2. Okay, so knowing that it's 8 choose 2, I want you to go ahead and work this one out, and then we'll go over the final answer. I did the hard part, so you do the rest. All right, so after we have this, before we start simplifying, we should get 8 factorial over 8 minus 2 factorial times 2 factorial. I got that straight from this formula sheet right here. Okay, and then when you simplify, you should get there are 28 different combinations. All right, last but not least, let's look at example 5 together. It says a yearbook editor has selected 14 photos, including one of you and one of your friend, to use in a collage for the yearbook. The photos are placed at random. There's room for 2 photos at the top of the page. What is the probability that your photo and your friend's photo are the 2 placed at the top of the page? Okay, so here we're wanting what is the probability. Okay, not how many different ways can we do it. Okay, so we can do this without any formulas, and this is the way I would probably do it. So let's just say top left and top right, although it doesn't really matter which one's left. Okay, so if I'm looking at the top right, we want me and my friend to be, one be the left, one be the right, doesn't matter which one's which. So the top left, there's 2 photos they can choose from, mine and my friend's, out of the 14 possibilities. Okay, well now, assuming one of us is chosen in the top left, the top right, there's only one of our photos left. So say they choose my friend on the left, all they have is me to choose from on the right that would help. They don't have 14 photos to choose from, they have 13 photos to choose from. Okay, so if I multiply these 2 numbers, I would get 2 over 13 times 14 is 182, which simplifies to 1 over 91. Okay, that's one way we can do it. Or we can do it by saying 14, well, let me move this up so we have enough room. 14 choose 2, and we use combinations because once again, it doesn't matter if I'm on the left, my friend's on the right, or my friend's on the left and I'm on the right. We're counting both of those a win. Okay, so that would be 14 factorial over 14 minus 2 factorial times 2 factorial. Okay, so this is just 14 times 13 times 12 factorial over 12 factorial times 2 factorial. 12 factorials go away. I'm left with 14 times 13 over 2, which equals 182 out of 2, which is 91 over 1, or just 91. So what this tells me is that there's 91 different combinations of choosing any 2 kids out of 14. Well, all we want is my friend and I. That's one of those 91 combinations. So the probability would just be 1 over 91. We get the same answer either way we do it.